Hello and welcome to another tutorial. Have you ever wanted to create a blast, a cannon blast? Then you came to the right place. Stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We even have resources for every type of discipline. So hop in and have fun. Well, we are in the file. As you can see, we have a really nice smoke simulation, we have a shockwave, we have a blast, we have some flames, and you will see eventually some sparks. So first of all, we need to load these Lemmics, right? And when you load the Lemmics from Maya, sometimes you got to scale them by a factor of 100 because the Maya uses centimeters and Houdini uses meters unless you configure the file in Maya. And I wanted to transform this so it's centered on the world. But this is only a personal utility I did for this particular case scenario. So I'll load in the camera. When you load in the camera, you get to import a Lemmic scene, choose the camera file and load in the camera file. Then I grabbed the assets, which were these cannons. As you can see, they are right here. And after that, I loaded in the animation. These are some of the animations I have. There are 3 movements, and I only chose one of them. I cached this out with a trail node, so we can have the velocity and central difference. This is useful. We save this, and we blast the one we need. As you can see, I'm also polyfilling this because I will be eventually doing a collision, and I need this to be basically waterproof. So now that I have this, we should move on to the collisions. How do I create the collisions? Well, in order to create the collisions, first of all, of course, we got to load in the asset, which is here. We need to mesh it clearly, and we need to BDB from polygons. As you can see, this is working flawlessly, and what I'm doing is to grab the point velocity from the trailer you remember we created before, and I'm creating a BDB volume called V right here. We should call this bell too, it's up to you guys. Then I'm grabbing the mesh and I'm time shifting this to the beginning of the animation, which is 1001. And I'm using a pointer form over this time shift again on the first frame, and I convert this. Why? Because I want to have a low poly solution to this collision, which is only 70,000 points, whereas if I go here, it's over 200 points. It's faster and it's pretty much the same. So with a pointer form, I'm basically mimicking the animation, as you can see. And it's a single mesh, which is going to be faster for the program. I'm also doing a trail node here to grab the central difference again, and I'm saying, hey, this is the cannon. So I'm grouping this with a merge. I'm basically caching this out, and what I'm trying to do here is to split them. The polygons from one side, I cache this out because the split function is very expensive, and the collision I could have done the same with an attaché, but I didn't, since I'm not going to use this as much as the polygon. So once that we have this, we need to go and hop into the first effects of all of them. This looks quite complex, but it's really simple to create. First of all, we need to grab the central point of this tube. It doesn't matter what it is, we need to grab the central. So we blast this out. Remember, with the letter S and with the A, you can do this kind of selection. With the shift, you can add on top of it. And I blast this out. I inverted the selection here, and I created a name. Well, you see, this set names is basically doing the following. I have an attribute wrangle, but basically what I'm doing is to create this. Hey, create a connectivity node first, right here. Set this to primitives so we can have all the pieces around here, which in this case is only one. so it's 0. And once you have this, set this to primitives and say, hey, my name is equal to the name you want, and change the name of the class, so 0, to a string. So now we have piz/0. And well, this is basically doing exactly the same. It's the same node configuration. If we hop in, this is the same. And we want to extract the centroid of this piece. This is very useful. It needs a name attribute, that's why I had to create it. And it saved it because I want everything to be really fast. As you can see, we have the velocity, the movement here. This is the out centroid. And what can we do with this information? For instance, we can grab the point and plug it into a copy to point. In this case, I want the normal to be equal to set 1. The set basically is on the right of my viewport. Here's the arrow. I don't know if you can see it. I'm going to place another background just in case. Here is the set. So now if we go to the camera and we watch closely, not this one but this one, we watch closely, we can see that the point is here. The normal, once I created, is pointing to the right. So with this I can create a pyro burst source, which on the frame 14 it will blast upwards. The start frame is 1014. It lasts 3 frames. It expands by 2. The direction is 7.13. I made a couple of changes on the initial side and the spread angle, and the burst components scale over duration, and basically, well, I'm basically getting these sources: density, temperature, and burn. The output that doesn't change at all, and I'm moving this pointing to the right. So when I copy to point, it basically matches the direction. So in context, it would look something like this. This is the source. It works. It's simple and elegant. And now what I want to do is to create a velocity. This already has some velocities out of the box, but I want to control them. So I multiply them a little bit so they point mostly to the right. And one thing is that I'm creating a random number and a threshold to remove all the points. So around these angles, I'm basically deleting some of the points so the source gets reduced. It's not so necessary here, but in other scenarios it will come in very handy. I'm also moving the velocities a little bit so they are not so uniform, as you can see, with some core noise and keeping coming. And at the end of the day, I'm just setting all the attributes from 0. The basically it will be equals to 1. The density will be using the nature, the normalized age. So when you are just born, you're 0, and when you die, you're 1. But if I do a fit 0 1 and I do 1 to 0, I'm basically inverting this. And I'm doing the same for the burn, the temperature, and the velocity. I'm just multiplying these velocity, so at the end of the line or of their life, they do not have so much velocity. Then I'm all rasterizing this, as you can see right here. I'm going to press D and go to dark mode so we can see this better. And in velocity, blurring this with a shatter of 1 and blur sample of 16 with a particle scale of 0.025 and a coverage scale of 4. You may ask yourself why this is blue, because I have a function. Basically, I'm copying this right here and pasting the relative reference right here. You can see it's well, basically the same, and then I'm using this one and I'm pasting it right here. Well, these are inverted, but the multiplication doesn't change the fact that it's the same. And then I'm dividing this by 4, so I have like a close relationship between the scale and the coverage scale. And this is how I do all my sources. Now that I have this will be out blast main. I want to use another again the central and a point replicate, and I'm going to use a time blend, and I'm going to simulate from frame 1013 on 2 sub-steps this situation. As you can see, it's like kind of a smoke which has a noise around, This is like the remnant smoke. The only thing it is all points. First context and birth is going to have a life expectancy of 3 with a life variance of 1, so they're going to live 3 seconds, and they're going to be deleted with a 1/10 of a second variance. And on the attributes, it's set initial velocity, and I basically saying, hey, move to the right and have a variance of 0.1, 0.1, and 0.1, and remember to have the ID attribute. On the pop force, I'm basically doing 1 on the amplitude and multiplicating this by the age. So when you're just born, you have 0, and when you're dying, you have 1. So you see at the beginning, this is very organized, and that when it gets older, it's going to have more distortion. That's about it. There's nothing else. I'm doing the same trick only for the density, and I'm rasterizing this here, density and velocity, with a velocity blur of 0.1 and 4 with a particle scale of 0.1. This will work, and it looks something like this. This is a very nice source, and this is the out remnant smoke. For the flame, this is a bit more complex, but you will understand it's very similar to the other one. I have a centroid, and I have a wrangle which has the velocity. In this case, it's 0.3. Replicating this with a shape of 0.2 and a seed of $f. I have to say this is 0.1 in this case, and I'm adding a little bit of noise with a swirl size of 1 and keep incoming as always. Time blend, I'm not helping in. Well, in this case, well, basically there's nothing. I'm just using what I have with a 0.1 and 0.05 negative back and use point velocity for interpolation. This will make the simulation look nicer. Sometimes this is useful, so give it a try, but it only works if you have velocities plugged in beforehand. And you have some kind of fast simulation like this one. I'm going to use a trail only on preserve original, so I have more points basically, and I'm going to add this based on ID. Remember that I created ID right here on the pop option. No, sorry, on the attributes, add ID attributes. So I'm creating this line with a sample, and I cache this out. As you can see, there are some lines. You would ask, or you would think these are the sprites, but they are not. I'm going to, in fact, based on the point, remember this is 0.04, and as you can see right here, I have plenty of points, and I'm deleting this based on the random number of a PT_num and a threshold based on this animation. As you can see, it will slowly disappear. I'm going to use this as, well, basically exactly the same I used to have here, but only density, burn temperature, and velocity. I'm going to add a little bit of noise to our velocities, and we can see then if we do an add. As you can see, before, after, before, after. Before and after, before and after. Perhaps this is a little bit too much, but you can always control this after hand. And basically I'm rasterizing burn, density, velocity, and temperature with these settings. This is out remnant flame. And one more source we need to create is a shockwave. The shockwave is based on a circle and based on the centroid. If we look the centroid, this is going to be used on the first frame to center this. But first of all, we have the circle, and we have a velocity which is normalized. Why do I create this? You can see there is a small velocity here, because when I scatter points, they will inherit the velocities. And I'm doing basically this. The velocity is a normalized position. It's pretty much the same. I could have even deleted this. It wouldn't make a difference at the end of the day, as you can see here, right? So we can delete this. And the distance is the length of the position, so I can see, I can tell if this is 0 and this is, I don't know, 15 meters for example. And I'm basically using this point so we can center this, so it moves with, or it should move with the animation. While not in this case, because this is time shifted, but if we don't time shift, we can move this around based on just the center X and set. I'm not using the Y, otherwise it would go on the air, and we need this to be on the floor. I'm using the rest position right here. This is going to match every time here, it's going to create an attribute called rest. So as you can see, I'm saving the position. I'm doing a little bit of noise. You will see why in a moment. And I'm matching this to the center. And why did I create a noise before? Because I can, if we go forwards, I can say that, hey, recover the position. So after the match size, I created this mask. I'm visualizing this with the mask button here with control and middle mouse and click on mask. So the mask is using the 8 and 2 function. The 8 and 2 function makes a gradient from negative P to positive P, as you can see right here. I'm using this in order to make a very nice circular mask where I can make stripes of values going on this direction. So now that I know this goes from P to negative pi, and I'm using a noise, see, as you can see this is noisy, I can recover the original position, so we can have like a more distorted kind of shape going on. What I'm doing here is to grab the mask and ramp it. When you make a value, a ramp from something that goes beyond 0 to 1, it will start repeating. So this goes from negative pi to pi, so it's going to repeat around 6 times. As you can see, 1, 2, 3, 4, 5, 6. We have 6 stripes being modified by this. You can always fit this value, so you can have X amount of repetitions. Then I'm multiplying this by the distance. Remember that I used to grab before the distance value, which is here. Yeah, the distance is the length of the position. And if we visualize this, we will see something along the lines of this. From 0 to 1. Well, from 0 to an X amount, which is normalized on the viewport. And knowing that, what I can do is I'm going to watch the mask again right here, and I can basically multiply based on the mask and an animation. Potentially, for example, grab one of these points and animate a fast expansion of points. This is a possibility, of course. The distance goes beyond 12, which is basically the radius. I'm deleting this because I want to have a perfect circle. For example, if I go 14, you will see the edges. I just want a circle. That's about it. There's no much more science beyond it. And if I go here, I'm using the same function, so I don't have the points all over the place. So, but I am animating this. I am animating this right here. As you can see, the function moves, and I'm creating this kind of nice gradient of mask. This is 0 and the radius 1. Right here, as you can see, 0 to 1. And basically, I'm deleting everything that goes beyond the threshold as before. And I'm using a point velocity to change a little bit the velocities. There we go. And I'm all doing another thing. I'm creating a float based on the distance from 0 to 12, and I'm basically multiplicating the density by this mult mask, and I'm also multiplying the mult by the mult float. What you got to understand basically is that if, for example, if I go into the density and I watch this density, I am controlling where do I want to have more or less density. That's about it. There's no much science, and when it comes from velocity, I'm basically multiplying by the mass. So if I don't have this, I will have velocity all over the place, which I only want at the center or where there is density. I'm also rasterizing this with the same idea based on density and velocity. As you can see, I'm creating a really nice explosion-like effect, which this will indeed work as intended. Okay, so let's hop into our first simulation, which is going to be the blast of the actual cannon. This is the most important part of the simulation. So let's hop in. This simulation is going to start at frame 1013. And it consists on a couple of things. First of all, as always, you need to create a PyroSparse solver, a SmokeSparse object, and plug in the sourcing part the following inputs. It's going to be a volume source, which is going to be grabbing our out blast main, which we created before. We're going to enlarge the fields, and we're going to source a field, so we can have density to density, burn to flame, temperature to divergence, this is a custom one, and temperature to temperature. Also velocity to velocity, I'm going to set the velocity scale to 4. Okay, so the only thing you need to understand here is that the temperature to divergence is some way of creating expansion. That's how the more temperature there is, the more divergence is going to be creating. And when we source burn, and it's going to create a flame, is basically, well, everywhere we have flame, we can have more settings being modified in the PyroSparse. That's the first blast source. Then we're going to use the same for the remnant smoke, but in this case the only thing we want to do is a density and a velocity, which we are going to be animating from 1 to 0 around here. As you can see, this is falling down because we don't want to have all the time remnant smoke. We merge these two guys and basically we plug it in here, and let's see how this looks without these macro solvers and without this, which I'm going to explain in just a bit. So I'm going to plug in this here, which is set to 1. You can basically ignore these two guys and let's see what happens. I'm going to lower this to 4 and let's see. As you can see, we have a cube because this method creates a cube. So I'm going to go backwards and I'm going to load in with this dop import field, and which has every single situation. So as you can see, this is quite weak. It's not good looking, but we can see we have a source. This is the remnant flame, and this is the expansion or the initial blast. But as you can see, there's no expansion, there's no flame. So let's grab a pyro bake and let's plug it in after the dop import and let's see what happens. I'm using the smoke and the fire set to these values. We can always compute the range, and this is what's going on. What I'm having on the PyroSparse is that I'm emitting smoke based on this ramp. I remapped it, and I'm also adding expansion on 0.4 based on this ramp. This is grabbing the flame field. The shape has a dissipation of 0.001, and I'm using an advection of BFECC with clamp. This will basically make the simulation look way better. On the simulation, I have a temperature diffusion 2.1, a cooling rate 0.999, and a buoyancy of 0.05 because I don't want it to go so high. That's about it. We're going to tick here so we can always see our simulation, and what I would like to have is more expansion. So how should I do this? Okay, there's a good trick, a very good trick which almost nobody knows, is that if you create an apply data after the sparse and a switch value, you can control how much injection of velocity, temperature, density, everything the solver has. So what you want to do is to unlock this with the unlock attribute right here. You allow editing of contents and hop in, and then do the same with the solver. And on the right side of our solver, multi-solver, we're going to create a gas repeat solver with an override minimum data. As you can see, this opens this value. We're only going to copy the name. You need to understand what's going on there. And on the switch value, copy it here. Basically, if we have a value of 1, we're basically each frame copying one time the sources. But I already have this animation. The animation goes from 7 to 1 on a split second, and let's see how it changes the simulation. Let's play. You will see it will take longer but immediately it's way stronger, and it's free. As you can see, it looks very nice, and it looks flawlessly. This is a good trick. You can put in any number you want. The difference is astonishing, and you will enjoy it. And how do we make this look a little bit more realistic? So let's turn on the merge, and let's start with the gas vortex confinement. What I did here is to create a multiplication value that goes from 1 to 3 and then goes back to 1, and I'm basically done this by adding it at a parameter interface and dragging in a float. I named it mult and mult, and that's how it. And I animated this and I pasted right here. I press a value of 2 and I basically grab this value, copy parameter, and I paste relative reference after the fact, and I multiply these two. In controlling this based on the temperature and this ramp, and that's how it. For example, this should start to look a little bit different. You will notice the difference at the end. This is more swirly, so it's like dragging in a little bit more. And I did basically the same for the disturbance with 45 on mult. On this it has to be on block base on 0.2, and on temperature from 0 to 0.3. Let's see what happens again. So you can see this is working. We are starting to have more detail on the edges, which I really like. I'm using also a gas wind set to the X position, so it's going to go to the back of our viewport, blasting, and it's barely noticeable, but it will slowly go to the back of our animation simulation. We have a gas diffuse. The gas diffuse blurs a little bit the smoke, which this kind of simulation have. A really small 0.01 will do the trick. And I'm also grabbing the collision. Remember that we used to have the out call BS SDF. Well, I grab the surface, the collision, the velocity, and the collision velocity. This is automatic if we go to collision. And with this, what I'm doing is to create a little bit of collision right here. It's barely noticeable. I could even delete this, but it's always nice to be as accurate as possible. And with this nice trick, we do have a very nice simulation. I'm going to go backwards and see how it looks on high res. On high res, it looks something like this. From camera, it's very fast, but it has like a nice expansion setting. We can obviously modify this a little bit more, so it has more shape. For example, the shape is not so quite correct, but it could be easily composed with a nice velocity blur and render time. So let's hop into the flame cannon. The flame cannon is a little bit different, but it's simpler in a way. So it's the remnant flame, burn, temperature, density, and velocity set to 3 with enlarge. And all I'm doing is to add a turbulence, a very high turbulence of 1 and 0.3 on swirl size with a control of speed. The speed is created right here and calculates speed value with a temperature diffusion of 0.1, cooling rate of 0.9, buoyancy of 0.1. Velocity is adding some flame, some smoke on the flame, and the shape has a nice dissipation. And the voxel size is something like this. And let's see how it looks. Oh, oops! I need to visualize this first. It looks quite nice. If I go into parabolic volume, it looks something like this, which is basically what I want. This has to this basically needs to last not so much, because remember guys, we are not emitting constantly. It's only like a small time frame of frames we need, and that's how it is. And to end this type of simulation, we did the exact same trick here. This is set to 4 and instantly set to 1 after this. We're going to visualize this on the dot import field. There we go. Let's move this value a little bit higher, for example by 4. so it loads in very fast. See, we have a really nice silhouette of very interesting shapes of distortion, and voila, it works instantly. There we go. And right here, all we did is grab the density by 2, velocity by 10, and yeah, I'm going to use a vertex confinement 2.3, a disturbance on 5, and a gas wind on 0.1 with a diffuse, and the canon collision is kept the same. We're only adding some dissipation. This is exactly the same, and the resizing is set to 0.1 because this is a very large simulation and I don't want to waste resources on my machine. On the high res, this looks something like this, which you might ask why this looks so bad, because we are visualizing the velocity, but once we only visualize the density, it looks very nice and fast. So after all the simulations, we are adding a convert which changed this to BDB. A vector mesh will merge all the velocities. As you can see, we have 3 velocity flows and now we have a only vector, and then I'm resampling this based on the voxel size. We could do, for example, voxel scale and say, hey, this should be smaller. This is in 60 and this is on 480. This is a very nice trick to lower the file size. And on the primitive, I'm also compressing this to 16-bit on BDB, so it's very easy for the machine to read. Okay, so moving forwards, we are going to grab again our centroid and we're going to transform this based on the pivot translate on centroid 0dx, 0dy, and 0dz. Basically, this moves the pivot to the center of the point, and I'm moving it a little bit backwards so it's inside of the canon. I'm also grabbing a velocity set to 3, so as you can see, this is the vector, and I'm point replicating this with a point velocity to randomize this a little bit as we used to do, and I'm deleting a couple of points. This is not an animation. And I'm doing the same here with another value and another value right here, so we have more or less points. These are the points, and these will be strips of lights, like for example sparks. This is the same trick we did on the Doctor Strange tutorial. So if you saw this, you can skip this part. I'm going to group all of this, and I'm going to remove this based on an animation, as the old trick we used to do, and this is the source. What I'm doing is also grabbing a life of 0.3, and all I'm doing here on the pop network is to basically use a pop at back by volume. I'm grabbing the flame canon B and velocity of 4 with an animation that goes from 4 to basically 1. As you can see, this is following the shape of the smoke, and that's about it. There's nothing else. These are the particles. We can add a bunch more, and I'm splitting based on the points. The points will only be shaded based on this point bob, which I'm going to cover, which is basically similar to this one, and then I'm copying some spheres so we can interpret a little bit better what I'm doing. As you can see, this is very nice looking. So let's do the same with the points, which are meant to be these lines. Since we have the ID from the source right here, we are basically adding this by group on an ID. Let's hop in here and let's grab the bind H, hence the normalized H as explained before, and let's run this with a really nice spline. Basically, I'm inverting this value, as you can see here. I'm also setting this to be a multiplication of the width, because later on I'm multiplicating this. As you can see, this is a really nice trick, and basically this ramp is getting multiplied by this value, so we can increase this by a lot more and do any kind of ramp we want. So moving on, I'm also plugging in the H right here on normalization, which is already normalized, but I could potentially move this value even more. And I'm grabbing the colors. I'm also multiplicating the colors by the length of the velocity right here, So where there is more velocity, there is going to be more brightness. This is the ramp I decided to create, and that's about it. Then I'm also doing some alpha based on the clamp of the length of the CD, based going from 0 to 1. This is not necessary, in fact, we can delete this, but it's always nice to visualize this beforehand. So we have a resample with interpolating curves, just in case, but in fact we should do, in order to visualize the curve, we need 3 trail length instead of 2, so interpolated curves will be useless here. But what I'm doing this is to also using the edge of the valley, so at the beginning is 0 and at the end is 1 of these turbans, as you can see, and applying this based on a ramp to a multi constant of 1 in this case, and to the amplitude of a noise which is being added to the original position. So if we delete this is the original position, and we are only adding this based on how long are these particles living. Of course, we can change this. As you can see, this is like a mask. This is very useful. And the polywire is basically grabbing the width attribute we created right here on the top. So that's why it's increasing. I'm also doing a normal, and I'm merging these two guys together. The same trick is being applied to the P scale right here. Instead of width is P scale, and the copy to point uses this P scale attribute, so we can modify these spheres very nicely. And this is how we create a very nice spiky effect. So all the sources combined together would look something like this. Let's merge this guy here with this shockwave, and let's see what happens if we add this, so we can increase the, there we go. If we add some lights, this is how it looks. It looks very nice, very complete effect, and render should be very nice to look at. Hey, I hope that you enjoyed the tutorial. If you have any question regarding the explosion or any type of effects, please share the Discord channel or leave a comment down in the comment section. See ya.